Saturn, from Wikipedia, the free encyclopedia, at en.wikipedia.org. This recording was last updated on August 18, 2013. Saturn is the sixth planet from the Sun, and the second largest planet in the solar system, after Jupiter. Named after the Roman god of agriculture, Saturn, its astronomical symbol represents the god's sickle. Saturn is a gas giant with an average radius about 9 times that of Earth. While only 1/8 the average density of Earth, with its larger volume, Saturn is just over 95 times more massive than Earth. Saturn's interior is probably composed of a core of iron, nickel, and rock, silicon and oxygen compounds, surrounded by a deep layer of metallic hydrogen, an intermediate layer of liquid hydrogen and liquid helium, and an outer gaseous layer. The planet exhibits a pale yellow hue due to ammonia crystals in its upper atmosphere. Electrical current within the metallic hydrogen layer is thought to give rise to Saturn's planetary magnetic field, which is slightly weaker than Earth's, and around 1/20th the strength of Jupiter's. The outer atmosphere is generally bland and lacking in contrast, although long-lived features can appear. Wind speeds on Saturn can reach 1,800 kilometers per hour, that's 1,100 miles per hour, faster than on Jupiter, but not as fast as those on Neptune. Saturn has a prominent ring system that consists of 9 continuous main rings and 3 discontinuous arcs, composed mostly of ice particles with a smaller amount of rocky debris and dust. 62 known moons orbit the planet. 53 are officially named. This does not include the hundreds of moonlets within the rings. Titan, Saturn's largest and the solar system's second largest moon, is larger than the planet Mercury, and is the only moon in the solar system to retain a substantial atmosphere. Contents: Section 1. Physical Characteristics. Section 2. Atmosphere. Section 3. Magnetosphere. Section 4. Orbit and rotation. Section 5. Planetary rings. Section 6. Natural satellites. Section 7. History of exploration. Section 8. Observation. Section 9. In culture. Section 10. Statistics. Section 1. Physical characteristics. Saturn is classified as a gas giant planet because the exterior is predominantly composed of gas, and it lacks a definite surface, although it may have a solid core. The rotation of the planet causes it to take the shape of an oblate spheroid, that is, it is flattened at the poles and bulges at the equator. Its equatorial and polar radii differ by almost 10%, 60,268 kilometers versus 54,364 kilometers respectively. Jupiter, Uranus, and Neptune, the other gas giants in the solar system, are also oblate, but to a lesser extent. Saturn is the only planet of the solar system that is less dense than water, about 30% less. Although Saturn's core is considerably denser than water, the average specific density of the planet is 0.69 grams per centimeter cubed, due to the gaseous atmosphere. Jupiter has 318 times the Earth's mass, while Saturn is 95 times the mass of the Earth. Together, Jupiter and Saturn hold 92% of the total planetary mass in the solar system. Section 1.1. Internal structure. Saturn is termed a gas giant, but it is not entirely gaseous. The planet primarily consists of hydrogen, which becomes a non-ideal liquid when the density is above 0.01 grams per centimeter cubed. This density is reached at a radius containing 99.9% of Saturn's mass. The temperature, pressure, and density inside the planet all rise steadily toward the core, which, in the deeper layers of the planet, cause hydrogen to transition into a metal. Standard planetary models suggest that the interior of Saturn is similar to that of Jupiter, having a small rocky core surrounded by hydrogen and helium with trace amounts of various volatiles. This core is similar in composition to the Earth, but more dense. Examination of the gravitational moment of the planet, in combination with physical models of the interior, allowed French astronomers Didier Somon and Tristan Gollot to place constraints on the mass of the planet's core. In 2004, they estimated that the core must be 9 to 22 times the mass of the Earth, which corresponds to a diameter of about 25,000 kilometers. This is surrounded by a thick liquid metallic hydrogen layer, followed by a liquid layer of helium-saturated molecular hydrogen that gradually transitions into gas with increasing altitude. The outermost layer spans 1,000 kilometers and consists of a gaseous atmosphere. Saturn has a very hot interior, reaching 1,700 degrees Celsius at the core, and the planet radiates 2.5 times more energy into space than it receives from the Sun. Most of this extra energy is generated by the Kelvin-Helmholtz mechanism of slow gravitational compression, but this alone may not be sufficient to explain Saturn's heat production. An additional mechanism may be at play, whereby Saturn generates some of its heat through the raining out of droplets of helium deep in its interior. As the droplets descend through the lower density hydrogen, the process releases heat by friction and leaves the outer layers of the planet depleted of helium. These descending droplets may have accumulated into a helium shell surrounding the core. Section 2. Atmosphere. The outer atmosphere of Saturn contains 96.3% molecular hydrogen and 3.25% helium. The proportion of helium is significantly deficient compared to the abundance of this element in the Sun. The quantity of elements heavier than helium are not known precisely, but the proportions are assumed to match the primordial abundances from the formation of the solar system. The total mass of these heavier elements is estimated to be 19 to 31 times the mass of the Earth, with a significant fraction located in Saturn's core region. Trace amounts of ammonia, acetylene, ethane, propane, phosphine, and methane have been detected in Saturn's atmosphere. The upper clouds are composed of ammonia crystals, while the lower-level clouds appear to consist of either ammonium hydrosulfide or water. Ultraviolet radiation from the Sun causes methane photolysis in the upper atmosphere, leading to a series of hydrocarbon chemical reactions, with the resulting products being carried downward by eddies and diffusion. This photochemical cycle is modulated by Saturn's annual seasonal cycle. Section 2.1. Cloud layers. Saturn's atmosphere exhibits a banded pattern similar to Jupiter's, but Saturn's bands are much fainter and are much wider near the equator. The nomenclature used to describe these bands is the same as on Jupiter. Saturn's finer cloud patterns were not observed until the flybys of the Voyager spacecraft during the 1980s. Since then, Earth-based telescopy has improved to the point where regular observations can be made. The composition of clouds varies with depth and increasing pressure. In the upper cloud layers, with the temperature in the range of 100 to 160 Kelvin and pressures extending between 0.5 and 2 bar, the clouds consist of ammonia ice. Water clouds begin at a level where the pressure is about 2.5 bar and extend down to 9.5 bar, where temperatures range from 185 to 270 Kelvin. Intermixed in this layer is a band of ammonium hydrosulfide ice, lying in the pressure range of 3 to 6 bar, with temperatures of 235 to 290 Kelvin. Finally, the lower layers, where pressures are between 10 to 20 bar and temperatures are between 270 and 330 Kelvin, contains a region of water droplets with ammonia in aqueous solution. Saturn's usually bland atmosphere occasionally exhibits long-lived ovals and other features common on Jupiter. In 1990, the Hubble Space Telescope observed an enormous white cloud near Saturn's equator, which was not present during the Voyager encounters, and in 1994 another, smaller storm was observed. The 1990 storm was an example of a great white spot, a unique but short-lived phenomenon which occurs once every Saturnian year,
or roughly every 30 Earth years, around the time of the Northern Hemisphere's summer solstice. Previous great white spots were observed in 1876, 1903, 1933, and 1960, with the 1933 storm being the most famous. If the periodicity is maintained, another storm will occur in about 2020.
The winds on Saturn are the second fastest among the solar system's planets. Voyager data indicate peak easterly winds of 500 meters a second, that's 1,800 kilometers per hour. In images from the Cassini spacecraft during 2007, Saturn's northern hemisphere displayed a bright blue hue, similar to Uranus. The color was most likely caused by Rayleigh scattering. Infrared imaging has shown that Saturn's south pole has a warm polar vortex, the only known example of such a phenomenon in the solar system. Whereas temperatures on Saturn are normally minus 185 degrees Celsius, temperatures on the vortex often reach as high as minus 122 degrees Celsius, believed to be the warmest spot on Saturn.
Section 2.2 North Pole Hexagon Cloud Pattern. A persisting hexagonal wave pattern around the north polar vortex in the atmosphere at about 78 degrees north was first noted in the Voyager images. The straight sides of the northern polar hexagon are each approximately 13,800 kilometers long, or 8,600 miles long, making them larger than the diameter of the Earth. The entire structure rotates with a period of 10 hours, 39 minutes, 24 seconds, the same period as that of the planet's radio emissions, which is assumed to be equal to the period of rotation of Saturn's interior. The hexagonal feature does not shift in longitude like the other clouds in the visible atmosphere.
The pattern's origin is a matter of much speculation. Most astronomers believe it was caused by some standing wave pattern in the atmosphere. Polygonal shapes have been replicated in the laboratory through differential rotation of fluids. Section 2.3 South Pole Vortex. HST imaging of the South Polar region indicates the presence of a jet stream, but no strong polar vortex nor any hexagonal standing wave. NASA reported in November 2006 that Cassini had observed a hurricane-like storm locked to the South Pole that had a clearly defined eyewall. This observation is particularly notable because eyewall clouds had not previously been seen on any planet other than Earth. For example, images from the Galileo spacecraft did not show an eyewall in the Great Red Spot of Jupiter. The South Pole storm may have been present for billions of years. This vortex is comparable to the size of the Earth, and it has winds of 550 kilometers per hour. Section 2.4 Other Features. Cassini has observed a series of cloud features nicknamed string of pearls, found in northern latitudes. These features are cloud clearings that reside in deeper cloud layers.
Section 3 Magnetosphere.
Saturn has an intrinsic magnetic field that has a simple symmetric shape, a magnetic dipole. Its strength at the equator, 0.2 Gauss or 20 microtesla, is approximately 1/20th of that of the field around Jupiter, and slightly weaker than Earth's magnetic field. As a result, Saturn's magnetosphere is much smaller than Jupiter's. When Voyager 2 entered the magnetosphere, the solar wind pressure was high, and the magnetosphere extended only 19 Saturn radii, or 1.1 million kilometers, that's 712,000 miles, although it enlarged within several hours, and remained so for about 3 days. Most probably, the magnetic field is generated similarly to that of Jupiter, by currents in the liquid metallic hydrogen layer called a metallic hydrogen dynamo. This magnetosphere is efficient at deflecting the solar wind particles from the Sun. The moon Titan orbits within the outer part of Saturn's magnetosphere and contributes plasma from the ionized particles in Titan's outer atmosphere. Saturn's magnetosphere, like Earth's, produces aurorae.
Section 4 Orbit and Rotation. The average distance between Saturn and the Sun is over 1,400,000,000 kilometers, or 9 AU. With an average orbital speed of 9.69 kilometers per second, it takes Saturn 10,759 Earth days, or about 29.5 years, to finish one revolution around the Sun. The elliptical orbit of Saturn is inclined 2.48 degrees relative to the orbital plane of the Earth. Because of an eccentricity of 0.056, the distance between Saturn and the Sun varies by approximately 155 million kilometers between perihelion and aphelion, which are the nearest and most distant points of the planet along its orbital path, respectively. The visible features on Saturn rotate at different rates depending on latitude, and multiple rotation periods have been assigned to various regions, as in Jupiter's case. System 1 has a period of 10 hours, 14 minutes, 0 seconds, or 844.3 degrees per day, and encompasses the equatorial zone, which extends from the northern edge of the south equatorial belt to the southern edge of the north equatorial belt.
All other Saturnian latitudes have been assigned a rotation period of 10 hours, 38 minutes, 25.4 seconds. That's 810.76 degrees per day, which is System 2. System 3, based on radio emissions from the planet in the period of the Voyager flybys, has a period of 10 hours, 39 minutes, 22.4 seconds. That's 810.8 degrees per day. Because it is very close to System 2, it has largely superseded it. A precise value for the rotation period of the interior remains elusive. While approaching Saturn in 2004, the Cassini spacecraft found that the radio rotation period of Saturn had increased appreciably to approximately 10 hours, 45 minutes, 45 seconds, plus or minus 36 seconds. In March 2007, it was found that the variation of radio emissions from the planet did not match Saturn's rotation rate. This variance may be caused by geyser activity on Saturn's moon Enceladus. The water vapor emitted into Saturn's orbit by this activity becomes charged and creates a drag upon Saturn's magnetic field, slowing its rotation slightly relative to the rotation of the planet. The latest estimate of Saturn's rotation, based on a compilation of various measurements from the Cassini, Voyager, and Pioneer probes, was reported in September 2007, and is 10 hours, 32 minutes, 35 seconds. Section 5. Planetary Rings. Saturn is probably best known for the system of planetary rings that makes it visually unique. The rings extend from 6,630 kilometers to 120,700 kilometers above Saturn's equator, average approximately 20 meters in thickness, and are composed of 93% water ice with traces of Tholen impurities and 7% amorphous carbon. The particles that make up the rings range in size from specks of dust up to 10 meters. While the other gas giants also have ring systems, Saturn's is the largest and most visible. There are two main hypotheses regarding the origin of the rings. One hypothesis is that the rings are remnants of a destroyed moon of Saturn. The second hypothesis is that the rings are left over from the original nebular material from which Saturn formed. Some ice in these central rings comes from the moon Enceladus's ice volcanoes. In the past, astronomers believed the rings formed alongside the planet when it formed billions of years ago. Instead, the age of these planetary rings is probably some hundreds of millions of years. Beyond the main rings, at a distance of 12 million kilometers from the planet, is the sparse Phoebe ring, which is tilted at an angle of 27 degrees to the other rings, and, like Phoebe, orbits in retrograde fashion. Some of the moons of Saturn, including Pandora and Prometheus, act as shepherd moons to confine the rings and prevent them from spreading out. Pan and Atlas cause weak linear density waves in Saturn's rings that have yielded more reliable calculations of their masses. The age of these planetary rings is probably hundreds of millions of years old, in contrast to previous thoughts that the rings formed alongside the planet when it formed billions of years ago, and their fate include spiraling inward toward the planet, or the boulders forming the rings colliding with each other and disappearing. For more detailed information, please see the Wikipedia article Rings of Saturn.
Section 6. Natural Satellites.
Saturn has at least 150 moons, 53 of which have formal names.
Titan, the largest, comprises more than 90% of the mass in orbit around Saturn, including the rings.
Saturn's second largest moon, Rhea, may have a tenuous ring system of its own, along with a tenuous atmosphere.
Many of the other moons are very small. 34 are less than 10 kilometers in diameter, and another 14 less than 50 kilometers,
but larger than 10 kilometers.
Traditionally, most of Saturn's moons have been named after Titans of Greek mythology.
Titan is the only satellite in the solar system with a major atmosphere, in which a complex organic chemistry occurs. It is also the only satellite with hydrocarbon lakes. On June 6, 2013, scientists at the IAA-CSIC reported the detection of polycyclic aromatic hydrocarbons in the upper atmosphere of Titan, a possible precursor for life. Saturn's moon Enceladus has often been regarded as a potential base for microbial life. Evidence of this life includes the satellite's salt-rich particles having an ocean-like composition that indicates most of Enceladus's expelled ice comes from the evaporation of liquid salt water. For more detailed information, please see the Wikipedia article Moons of Saturn. Section 7. History of Exploration.
There are three main phases of observation and exploration of Saturn. The first era was ancient observations, such as with the naked eye, before the invention of modern telescopes.
Starting in the 17th century, progressively more advanced telescopic observations from Earth have been made.
The other type is visitation by spacecraft, either by orbiting or flyby. In the 21st century, observations continue from the Earth, or Earth-orbiting observatories, and from the Cassini orbiter at Saturn. Section 7.1. Ancient Observations. Saturn has been known since prehistoric times. In ancient times, it was the most distant of the 5 known planets in the solar system, excluding Earth, and thus a major character in various mythologies.
Babylonian astronomers systematically observed and recorded the movements of Saturn.
In ancient Roman mythology, the god Saturnus, from which the planet takes its name,
was the god of agriculture.
The Romans considered Saturnus the equivalent of the Greek god Kronos. The Greeks had made the outermost planet sacred to Kronos, and the Romans followed suit.
Ptolemy, a Greek living in Alexandria, observed an opposition of Saturn, which was the basis for his determination of the elements of its orbit. In Hindu astrology, there are 9 astrological objects, known as Navagrahas. Saturn, one of them, is known as Shani, which judges everyone based on the good and bad deeds performed in life.
Ancient Chinese and Japanese culture designated the planet Saturn as the Earth star. This was based on 5 elements, which were traditionally used to classify natural elements. In ancient Hebrew, Saturn is called Shabbathai. Its angel is Cassiel. Its intelligence, or beneficial spirit, is Agiel, and its spirit, darker aspect, is Zazel. In Ottoman Turkish, Urdu, and Malay, its name is Zuhal.
For more detailed information, please see the Wikipedia article Saturn, Mythology. Section 7.2. European Observations from the 17th to the 19th centuries.
Saturn's rings require at least a 15 mm diameter telescope to resolve, and thus were not known to exist until Galileo first saw them in 1610. He thought of them as 2 moons on Saturn's sides. It was not until Christian Huygens used a greater telescopic magnification that this notion was refuted. Huygens also discovered Saturn's moon Titan. Sometime later, Giovanni Domenico Cassini discovered 4 other moons, Iapetus, Rhea, Tethys, and Dione. In 1675, Cassini also discovered the gap, now known as the Cassini division. No further discoveries of significance were made until 1789, when William Herschel discovered 2 further moons, Mimas and Enceladus. The irregularly shaped satellite Hyperion, which has a resonance with Titan, was discovered in 1848 by a British team. In 1899, William Henry Pickering discovered Phoebe, a highly irregular satellite that does not rotate synchronously with Saturn as the larger moons do. Phoebe was the first such satellite found, and it takes more than a year to orbit Saturn in a retrograde orbit. During the early 20th century, research on Titan led to the confirmation in 1944 that it had a thick atmosphere, a feature unique among the solar system's moons.
Section 7.3 Modern NASA and ESA probes. Section 7.3.1 Pioneer 11 flyby. Pioneer 11 carried out the first flyby of Saturn in September 1979, when it passed within 20,000 kilometers of the planet's cloud tops. Images were taken of the planet and a few of its moons, although their resolution was too low to discern surface detail. The spacecraft also studied Saturn's rings, revealing the thin F-ring and the fact that dark gaps in the rings are bright when viewed at high phase angle towards the Sun, meaning that they contain fine light-scattering material. In addition, Pioneer 11 measured the temperature of Titan. Section 7.3.2 Voyager flybys.
In November 1980, the Voyager 1 probe visited the Saturn system. It sent back the first high-resolution images
of the planet, its rings, and satellites.
Surface features of various moons were seen for the first time. Voyager 1 performed a close flyby of Titan, greatly increasing our knowledge of the atmosphere of the moon. It also proved that Titan's atmosphere is impenetrable in visible wavelengths, so no surface details were seen. The flyby also changed the spacecraft's trajectory out from the plane of the solar system. Almost a year later, in August 1981, Voyager 2 continued the study of the Saturn system. More close-up images of Saturn's moons were acquired, as well as evidence of changes in the atmosphere and the rings. Unfortunately, during the flyby, the probe's turnable camera platform stuck for a couple of days, and some planned imaging was lost. Saturn's gravity was used to direct the spacecraft's trajectory towards Uranus. The probes discovered and confirmed several new satellites orbiting near or within the planet's rings. They also discovered the small Maxwell gap, a gap within the C ring, and the Keeler gap, a 42-kilometer wide gap in the A ring.
Section 7.3.3 Cassini-Huygens spacecraft.
On July 1, 2004, the Cassini-Huygens spacecraft performed the SOI, Saturn Orbit Insertion, maneuver and entered into orbit around Saturn. Before the SOI, Cassini had already studied the system extensively. In June 2004, it had conducted a close flyby of Phoebe, sending back high-resolution images and data. Cassini's flyby of Saturn's largest moon, Titan, has captured radar images of large lakes and their coastlines, with numerous islands and mountains. The orbiter completed 2 Titan flybys before releasing the Huygens probe on December 25, 2004. Huygens descended onto the surface of Titan on January 14, 2005, sending a flood of data during the atmospheric descent and after landing.
Cassini has since conducted multiple flybys of Titan and other icy satellites. Since early 2005, scientists have been tracking lightning on Saturn. The power of the lightning is approximately 1,000 times that of lightning on Earth. In 2006, NASA reported that, through images, the Cassini probe found evidence of liquid water reservoirs that erupt in geysers on Saturn's moon Enceladus. Images had shown jets of icy particles being emitted into orbit around Saturn from vents in the moon's south polar region. According to Dr. Andrew Ingersoll of the California Institute of Technology, quote, "Other moons in the solar system have liquid water oceans covered by kilometers of icy crust. What's different here is that pockets of liquid water may be no more than tens of meters below the surface." Unquote. In May 2011, NASA scientists at an Enceladus focus group conference reported that Enceladus, quote, "is emerging as the most habitable spot beyond Earth in the solar system for life as we know it." Cassini probe photographs have led to other significant discoveries. They have revealed a previously undiscovered planetary ring outside the brighter main rings of Saturn and inside the G and E rings. The source of this ring is believed to be the crashing of a meteoroid off two of the moons of Saturn. In July 2006, Cassini images provided evidence of hydrocarbon lakes near Titan's North Pole, the presence of which were confirmed in January 2007.
In March 2007, additional images near Titan's North Pole discovered hydrocarbon seas, the largest of which is almost the size of the Caspian Sea. In October 2006, the probe detected an 8,000-kilometer diameter hurricane with an eyewall at Saturn's South Pole. From 2004 to November 2, 2009, the probe has discovered and confirmed 8 new satellites. Its primary mission ended in 2008, when the spacecraft had completed 74 orbits around the planet.
The probe's mission was extended to September 2010, and then extended again to 2017, to study a full period of Saturn's seasons. For more detailed information on the history of Saturn's exploration, please see the Wikipedia article Exploration of Saturn. Section 8. Observation.
Saturn is the most distant of the 5 planets easily visible to the naked eye, the other 4 being Mercury, Venus, Mars, and Jupiter. Uranus and occasionally 4 Vesta are visible to the naked eye in very dark skies. Saturn appears to the naked eye in the night sky as a bright yellowish point of light, whose magnitude is usually between +1 and 0, and takes approximately 29.5 years to make a complete circuit of the ecliptic against the background constellations of the zodiac.
Most people will require optical aid, very large binoculars or a small telescope, magnifying at least 30 times to clearly resolve Saturn's rings.
While it is a rewarding target for observation for most of the time it is visible in the sky, Saturn and its rings are best seen when the planet is at or near opposition, the configuration of a planet when it is at an elongation of 180 degrees, and thus appears opposite the Sun in the sky. During the opposition of December 17, 2002, Saturn appeared at its brightest, due to a favorable orientation of its rings relative to the Earth.
But Saturn was closer to the Earth and Sun in late 2003. Section 9. In Culture. Saturn in astrology is the ruling planet of Capricorn, and traditionally Aquarius.
Saturn, the bringer of old age, is a movement in Gustav Holst's The Planets. The Saturn family of rockets were developed by a team of mostly German rocket scientists, led by Werner von Braun, to launch heavy payloads to Earth orbit and beyond. Originally proposed as a military satellite launcher, they were adopted as the launch vehicles for the Apollo program.
The day Saturday is named after Saturn, which itself is derived from the Roman god of agriculture, Saturn, linked to the Greek god Kronos. In Saturn's Rings is an upcoming movie from director Steven von Vuren about Saturn. It features more than 1 million photographs of the planet assembled with various techniques. The film is expected to be released in early 2014. For more detailed information, please see the Wikipedia article Saturn in Fiction. Section 10. Statistics. Orbital characteristics. Epoch J2000. Aphelion 1,513,325,783 kilometers, or 10.11595804 AU. Perihelion 1,353,572,956 kilometers, or 9.04807635 AU. Semi-major axis 1,433,449,370 kilometers, or 9.5821720 AU. Eccentricity 0.055723,219. Orbital period 10,759.22 days, or 29.4571 years, or
24,491.07 Saturn solar days. Synodic period, 378.09 days. Average orbital speed, 9.69 kilometers per second. Mean anomaly, 320.346750 degrees. Inclination, 2.48524 degrees to the ecliptic, or 5.51 degrees to Sun's equator, or 0.93 degrees to invariable plane. Longitude of ascending node, 113.642811 degrees. Argument of perihelion, 336.013862 degrees.
Satellites, 62 with formal designations. Innumerable additional moonlets.
Physical characteristics. Equatorial radius, 60,268 plus or minus 4 kilometers, or 9.4492 Earth. Polar radius, 54,364 plus or minus 10 kilometers, or 8.5521 Earth. Flattening, 0.09796 plus or minus 0.00018. Surface area, 4.27 times 10 to the 10 kilometers squared, or 83.703 Earths. Volume, 8.2713 times 10 to the 14th kilometers cubed, or 763.59 Earths. Mass, 5.6846 times 10 to the 26 kilograms, or 95.152 Earths. Mean density, 0.687 grams per centimeter cubed, less than water. Equatorial surface gravity, 10.44 meters per second squared, or 1.065 g. Escape velocity, 35.5 kilometers per second. Sidereal rotation period, 10.57 hours, or 10 hours 34 minutes. Equatorial rotation velocity, 9.87 kilometers per second, or 35,500 kilometers per hour. Axial tilt, 26.73 degrees. North Pole right ascension, 2 hours 42 minutes 21 seconds, or 40.589 degrees. North Pole declination, 83.537 degrees. Albedo, bond, 0.342. Albedo, geometric, 0.47. Mean surface temperature at the 1 bar level, 134 degrees Kelvin. Mean surface temperature at the 0.1 bar level, 84 degrees Kelvin. Apparent magnitude, positive 1.47 to negative 0.24. Angular diameter, 14.5 to 20.1, excludes rings. Atmosphere. Scale height, 59.5 kilometers. Composition, 96% hydrogen, 3% helium, 0.4% methane, 0.01% ammonia, 0.01% hydrogen deuteride, 0.0007% ethane. Ices: ammonia, water, ammonium hydrosulfide. You have just finished listening to Saturn from Wikipedia, the free encyclopedia. This recording was last updated on August 18th, 2013. This sound file and all text in the article are licensed under the Creative Commons Attribution Share Alike 3.0 Unported license, available at creativecommons.org/licenses/by-sa/3.0.